Okay, again, with the so far I've talked about the nodes and what's happening inside the network, multiple devices, etc. Everything is happening here, a big battle. After that, through a southbound API, I will send informations to the controller, which resides in here inside the appliance of the SDN, of the automation, whatever. And there will be a northbound API that will trans or exchange all of those information to an application that I can see by my eyes and understand, just like we saw in the GUI of the DNA center that we have verified or expressed in 2 videos ago. So what are those applications? Those actually are called the configuration management mechanisms, because you will manage everything and you will configure everything from here, from this central point of view, from this graphic user interface. These are actually the applications that you use to automate. All of them requires CLI and scripting, which means, do you remember the first time of creating or building a big automated network? It was about having a set of professional engineers who understand programmability and automate and scripting. They will create a script or a CLI commands for, like, maybe enabling some interfaces, assign IP addresses, make some no shutdowns, exit, and save. All of these are some commands that are written in a single script, and they will be saved inside the server. In the future, the controller for every new device, it will take this initial config and push it down to this device, so that this device will receive it automatically once it's connected to the network, and will have automatic initial config saved inside it, and that's it. So this is CLI scripting. So all of these applications will definitely need CLI scripting for you for the first time, and in the future you will modify or you will administrate using GUI. Okay, and by GUI you can schedule a task. That task had previously, for only one time at its life, it had a CLI script for how to apply this task, okay, how to perform this task. That's it, saved inside the server. In the future, it will come through this GUI and hit that task at 3 a.m., apply, and leave the control to do the rest. But before that, ages before that, what happened in the first place is that there was a programming engineer who created a CLI commands or a scripting for that task to be performed. Okay, so first you will need to create a CLI, and in the future you will only use the GUI to schedule a task or manually instantiate an event, the same thing. Okay, so a CLI script will give a GUI result and a GUI future modification or application. Those applications that I need to talk about are Puppet, Chef, and Ansible, and we need to differentiate those three different applications in this very slide. Okay, so these three are, Puppet and Chef are almost similar, that I can talk about both of them under the same specifications, and Ansible is very different, very much better, very much easier, simpler, much more common and useful than these two. So Puppet and Chef, both of them uses the master agent relation. What is the master agent relation? It's about two codes, okay, of programming, of scripting. One of them inside the server, which is the controller, and the other one is inside the node, which is the router, which is each router in your network. There is 100 router in your network, there is a 100 agent code inside your network, and thus all of them will talk to the server. Okay, so this is the first thing. So what you need then, for every new device assigned or maybe installed in your network, you will need to install an agent script of Puppet or Chef inside this new device, so that it can talk to its CLI or to its, I'm sorry, master script up in the server, in the controller. So number one, they use the master agent relation. Number two, they use the pull model, which is an agent, which is a node, which is a router or a multi-layer switch, will periodically ask a master, the server, for event and actions, and pulls the script from it. So maybe like every 10 minutes, each router in your network will send a request, a pull request, maybe request, okay, to this server asking, hey, what's up? Anything needed from me right now? Do you have any task, operation, change? Do you need any logs? If there was something asked from the node, and that will be recorded inside the controller because you have already recorded that or asked that from the application and hit it apply or save in the first place, then the server or the controller will say, yes, you are router number one, please reboot yourself at 3 a.m. and router number 2, 3, 4 and 5, please upgrade yourself starting from 4 to 6 a.m. to after tomorrow, 2 days after from now, and after rebooting please send some logs to the server to me so I can record them. So if you ask, the server will tell you what you need to do. If you don't ask, the server won't. See, this is the big problem. But you should ask always. So there will always should be a direct reachability or connectivity between the nodes and the controller. This is number two. Number three and last, for the Puppet and Chef, also both of them uses what's called the Ruby language. This is not the language that builds the API, not the HTTP verbs, CRUD. This is not the language that encode data inside an API. This is the language that just built the application that you see by your eyes, okay, that you use, like the DNA center that we saw. It's called the Ruby language. Okay, so this is the language that built that web-based application that you saw with all those maybe windows, statistics, commands, orders, all those options and tools up there, and all the actions that I can perform down. This is all built by Ruby language, just in case I uses one of these two applications, which are Puppet and Chef. Okay, for Ansible, the first awesome thing is that it's agentless. Install a new router in your network and you don't need to install anything inside it regarding scripting or maybe automation. That's it. The controller will talk with it automatically. How that will happen? It's happened by using the push model. The push model actually is master, which is the controller inside the server, will push a configuration to the agent when there is a configuration that needed to be pushed down to the agent. Okay, so once you hit, like you change something, you design, deploy, you config something from your GUI through your application, and hit click in here also, and that's it, and then you click apply, automatically it will go through an API to the controller, which resides in here, through a northbound API. It's a REST-based API, mostly REST-based API. Once the controller receives this, it will say okay, so through a southbound API I will send it to router number 7, this guy over here, so it will be immediately happen, so that router number 7 will know that it should reboot right now. Or if the reboot or the config or the change should happen maybe like 6 hours from now, it will save it in the controller, and after 6 hours the controller will send it to the router so that the router does it immediately. Okay, and I believe it can be sent immediately in the first place and the router does it after 6 hours, and maybe I think this depends upon the type of the controller or the device itself, just in case the device knows that. Because actually, even for Cisco, all the devices that we have used so far in Cisco's are the Cisco devices that uses the software of iOS, and some of them uses the known common software of iOS XE. And this is the same iOS that you have used in the Cisco packet tracer, the same commands, the same everything. Okay, I'm sorry, for service providers, big companies that have big routers that have some 40 gig, 25 gig and 100 gig ports, interfaces per port. So we have a port, one interface that have a speed or a bandwidth of 100 gigabit per second. Those devices do not use iOS XE, they use another software called iOS XR. This is a much more complicated software, but it's very smart, it's very accurate, it's brilliant. I hope you will work with it, and just in case in the future you will not work with it, maybe you will not face any service provider devices, maybe you will find or you will deal with whatever type of Juniper Networks devices. All of the Juniper Networks devices, routers, switches, firewalls, all of them uses a software that's called June operating system, June OS. I hope I will make a Juniper course in the future. June OS is almost identical to the iOS XE in a lot of things, differs in the commands, but in the hierarchy and in the architecture of the design of the software, it looks like it. It looks like it. Okay, so this is the difference. The point or the moral of the story is that both June OS and iOS XR, they do not apply or they not perform a task once you hit enter. Like in the previous tasks, in the previous labs, I'm sorry, in the iOS XE, I used to enter to a router and interface fast Ethernet 00, IP address, such an IP, hit enter, that's it. This interface right now have an IP address. If you have done the same command in a June OS or iOS XR, both of them will not assign an IP address to a device, to the interface at all. They will do nothing. You give, like, maybe you will enter to an interface, you will make it hit no shutdown, give it IP address, subnet mask, maybe also some description, some sub interfaces config, etc. Maybe like 10 commands. In the end, after all these enter that you have hit it, nothing changed at all. You need to commit your change. You need to type the word commit, and then the router will process all these commands and it will apply them to the device. You see, so there is another type of committing, is that commit at 6 a.m. So the device itself, without automation, without anything, it can understand that all of the commands that you have been typing in the past maybe 15 minutes, all of them, you need them to get enrolled in the party, in the network, not now, tomorrow at 6 a.m. So okay, so the device will keep it inside its memory and it will apply it at 6 a.m. So the device can do that, can schedule a task for itself. This is not automation. These are like almost legacy devices. These are softwares that have been there like for 20 years from now. So there is such thing, yes, it has been developed through time, and there is such thing already. So you can schedule a task inside a device, and you can schedule a task using TCL that I've talked about before, inside an iOS XE device. So these things exist, but we need to understand them, we need to get their culture, we need to study them, make use of them, because they are really beneficial for us. Okay, so for Ansible, it's agentless. I've talked about that. It uses the push model, and lastly, just before we finish this video, it uses the YAML, the YAML language. Okay, so these are the differences between the Puppet Chef, I'm sorry, and Ansible. There is a fourth type that's called the Salt Stack, but it's not mentioned in our course, so I will not talk about it. It's a fourth application like Puppet Chef and Ansible. What you need to know, what Cisco wants you to know, are Puppet Chef and Ansible. What I hope for you to work in the future or study is the Ansible, because it's much simpler and better. You see, being agentless with a push model is much better. Okay, so I hope so far this is good and this is clear for you for those three applications that we have talked about and differentiate in this video. And after that, in the upcoming video, we'll talk about one last thing before we finish chapter 7. So thanks for watching, and I hope to see you in the final video. Goodbye.